Let me
Yes,
start
yes.
the recording. Now, what is a geometry, guys? Based on your understanding, what is a geometry? Hmm? What is a geometry?
The shape.
The shape. Okay. Well, nice answer. What else? What else?
It could be curved.
Using, yeah, you can.
What? What?
Using geometry, we can arrive some
Hmm.
calculations and everything we can done. It is defining the shape of the model or something.
Object.
Yeah,
Hmm.
object. Yeah.
Hmm. Okay. Okay. Well, what else? What else? What is the difference between
Geomet
like a 2D and 3D? What is the difference between like a 2D and 3D?
Z-axis.
Z axis only? Is only
In
the Z
2D we have
axis?
a lines, points. In 3D we have surfaces, solids.
Hmm.
in 2D we are just on a single plane, but in 3D that could be
Hmm.
many I
Hmm.
would say many
Let's see this
planes.
now. The
Solid, yeah.
first if I open this image in new tab, the first line, can
Hello
you guys
everyone,
tell me?
good morning.
Good morning, Manish. Good morning. Good morning. We just
I'm
started now.
5 minutes late actually. I was in a meeting, important
No
meeting.
problem.
So
We haven't started it anything. Okay. Well,
okay.
so nice strength today after long days again. Saying food, 13 people. Well,
Right.
fine then. This is the base actually. Please ask everyone to join the training, Manish, because the last day session, even you can go with the recorded as well. But the geometry, no. You understand? Okay.
Yeah, yeah.
Well, fine. So, what do you mean by 2D and 3D? We have some sort of a pictures on a screen. Which is the 2D and which is a 3D? This one is
2D,
2D,
this one,
2D,
this one.
3D,
3D, 2D,
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 3D,
3D,
3D, 3D,
All 3 days.
2D.
Perfect. Why? We have a where we have a z-axis. Okay. To create this, which is more complicated in Dynamo to create? Is it a 3D or 2D?
3D.
Wrong. 2D. Creating a 2D object in Dynamo, it's very, very complicated because you have to understand because we already have a node to create a cone. We have a node to create a cylinder. We have a node to create some sort of a pyramids. We have a node to create a like cuboids. But we don't have any nodes to create a triangle like a 2D triangle. You have to understand some sort of factors like the base of the entire training is, I mean, if you want to start playing with something, you have to understand the first thing is called points. The geometry, all the geometry starts with the points only. Okay, so if you're good in like a points, I mean like placing the points and playing with the points, you're perfect. And the second thing, how to connect. For example, if I show you this picture, do you understand anything here? Do you understanding anything here? What is this? What is the picture here? Can anyone say? We have a dot. We have a dots actually. Correct. We used to play with this when we are in childhood. Correct. So connecting the
Yeah,
dots.
right,
Okay. So
right.
I'm hypnotizing you. I'm taking you to your like again childhood. Okay. So where's the first point? So this is the first point, and I want to connect this point with the second one. Okay. So to connect this, I need to know where the start point is. To place the start point, to get the start, I mean, to get the point, whatever. We have a lot of nodes, we have a lot of strategies, we have a different kind of terminologies to play one point. Okay, and how do you exactly get the second point? There must be a logic, there must be a logic to place a second point. Why you are placing that point intentionally, or is it created by itself? Okay, to cross check. Now, is this going to be a line, or is this going to be a curve on the left side, or is this going to be a curve on the right side? What is the line and what is a curve? In mathematical derivations, like the curve and line both are same. Line and curve both are same. For example, if you stretch these 2 points of the curve, of this curve, okay, let's say, let's consider, let's hold a thread of like 1 meter thread, 1 meter thread on the two ends, and just give them a some sort of a sag, so it is acting like a curve. No, if you stretch it if you stretch it, now it becomes a line like this. Correct? In mathematical form, we generally, let me show you that picture. Say this. So where if you hold that, it's having even the green and blue lines, which are called even a lines, or even you can call it as a curves as well. But when it comes to the straight line, that is not only the line. In dynamo geometry or in general mathematical, we generally call that as a curve. Curve. That's it. Okay. If it is a generally, why we call this as a line? Because it's not a line, it is a segment. Line segment. That's called line segment. What do you mean by segment? A part of a line. For example, let's say this. I have a very lengthy line. So I have very lengthy. Oh, just give me a second. What happened? Okay, I'm so sorry. So we have one point here, and we have one point here. So this point is A, and this point is B. Generally, why I'm explaining the segments and all, because I'm going to share you some sort of a documents, like some sort of a PDFs, okay, where there are some sort of an like formulas. It looks like a formulas denoting AB on the top of a line on it, okay, and AB on the top of a line with the arrow direction. So what is this AB, and what is the AB line, and what is the AB arrow? These are we generally calling as a rays, RAY rays. Rays. Ray means like a sun rays. Okay. So it has a direction and where there is no end for it. For example, here is a sun and he is sending a rays to it. Now I want to get this point and I want to get this point. So this is a line, it's just a segment. And here this is a segment, another segment, another segment. Here there is no end actually. Okay. If you want to get the start point, this is a start point and this is an end point. No, you don't want the complete line. You don't want the complete line. You want to play with some sort of segment. Then we call it as a line segment. Line segment. Segment is just a part. Clear? Well, now, so line A and B. Generally, how we denotes like this, like this. So it's AB. No, there is direction. There is there is an opposite direction as well. Sometimes the line reflects both. Then we can call on both sides AB. Either it can be this side or on that side. We don't know. We are not sure. We are going to play with this all these rays and everything in today's session or next session. Okay. So the base of the entire training is a points, guys. The points you should understand, like how to get the point. You have a column in your model, and how to get that point. From that point, I want to create a one more point, and from that point for example, this is my column in my model and I want to get this point information. And how do I use this? So I want to create a one point here, and from this point I want to place one more structural column, and I want to connect this together with a some sort of a 45 degrees angle at some point. Okay, like for example, this is a column, this is a column, and this is a new column actually, and this one has to be connected like this, connected to the top of this, and to the top of this, or else no, top of this or mid of this. How do you exactly? So the translations, transformations, so everything that we are going to see in our future sessions. Okay, so I don't want to confuse you, like explaining you the points now, and some sort of concepts of points today and some sort of concepts of point later on. No, we are going to play with all the concepts like points and lines and curves today, and the surfaces and faces and vectors on like NURBS curve on some other day. And we have a very less time actually. Okay, so hope like everyone should attend to understand. If you miss one single topic, guys, seriously, you will not able to catch up the next session for sure. Okay, so whatever you feel, I mean, if it's like the company's meeting, I don't say anything. But if you have any reasons, if you're not available, I mean, don't say that no internet connection, very poor. Just recharge your mobile with, I mean, like, insert another sim and log in from your PC and connect it to like log in from your mobile and connect it to your PC, or do whatever you want. Okay, but don't skip the sessions. Just otherwise, like purchase one some sort of a dongle, I mean, like a routers or whatever it is. Okay, it worth around like 1,000 rupees or something. No, find out your own solution, but don't skip the sessions. Okay, well, because even some of, I mean, like you guys are going to ask me some sort of a things, even I'm not sure like how to do it, and we are going to play on live. We are going to see a lot of possibilities, and then we do understand, oh no, this, I mean, I'm not good at logic. If I'm not good at logic at your query, then I need your support again. Okay, so this is how it would be. Geometry is not that easy, very 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 complicated, very complicated. I'm seriously. Okay, well, now try to understand the basics first. The point determines a location. What do you mean by location? A point determines a location. What do you mean by that location? For example, if you notice it, our rivets, I mean, like for example, we have a, what do you call this? In our rivet, we have this directions, correct? We, let me, what do we call this? What do we call this? North direction and east direction and south direction, elevations, na? Elevations. So these are elevations, south and the west. Okay, so try to understand in the same way the dynamo also acting like a north, east, south, west. Okay, but how do you read it exactly? How do you read those exactly? In dynamo, you can't see the elevations. You will see the green line. So this is a green line. Okay, and you see red line, red line. So red is always on the right side. When you are playing with any geometry, okay, in Dynamo, make sure, let's say click new. This should be, just go to switch to the geometry view. That is all the drawings. This is the way you have to read. This is the way you have to read all the time. The red line always should be on the right side. Remember, okay, the red line should be always on the right side and the green on the top. Okay, simple RR, like RR. Okay, so red line should be in a right hand side. Okay, remember this. And now the basic point, I mean, generally, if you ask where is my actual point, if I want to place one point here, so this is going to be the center point. This is going to be the center point. Now I, if I place a point, it exactly plays here in the mid of this. Let me erase all the drawings. If I place this point, it will exactly place here. Now if I start placing anything, I want to place a circle from here, okay, with the same direction, okay, then it will exactly place here. No, this is going to be my coordinate point. It's my coordinate point. Okay. Well, so now I want to create a one more point. How do I play with the points? I want to create a one more point. Again, you have to take a point dot by coordinates. Okay. Well, let me show you all those together. Okay, so this is a point, and this is another point, this is another point, this is another point. We have another point. So we have a number of points. We have a number of points. Okay. Well, how do you connect these points? That is what a challenge. Let's say we have these points, we have the point, and we have another point. How do you connect this? Is it going to be a straight line, or is it going to be a curve, or is it going to be a ray? Whatever. Now, 2 to 3 and 3 to 4. Don't connect it blindly. Try to understand the angle difference bit from 1 to 3. So there is an angle. So what is angle? 45 degrees. We'll see how to create that angle, how to create that angles and play with the axis today. Okay, don't worry. 2 to 3. What is it? Oh, I think it's a 45 degrees. And connecting the third to the 4. And again, there is an angle. So let's consider it's like a 50 degrees angle. 4 to 5. I want to connect a point 4 to the 5 with the degrees of like something around 50 degrees angle again. 5 to 6. Again, something around like a 50. And 6 to 7. 6 to 7. Okay, I think it's like something around 40. So 7 to 8. Again, let's say it's a 45. So 8 to 9 and 9 to 10. So 10 to, where is 11 again? Here, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So finally, I'm done. Finally, I'm done. So I got my shape. So to play with the connecting the points. So first of all, the first quality of every person who is going to play with the geometry or like this kind of things, they should understand, they should vision something like how the 3D geometry can be created. Okay, and every geometry has to be seen with a shape of like a splitting into like, hey, why my escape isn't working? Yeah. So you have to see that first quality for every geometry person needed vision with a section view. Like, this is what my geometry. I have something in my mind. I want to create this. How do I create that? How can I create that? How can I create that? How should I create that? So if I cut a section, how it looks like. If I cut a section on the other elevation, like how it looks like from the top, how it looks like. No, this is how you need a vision to create any geometry. Then only you can play with it. Otherwise, no. Okay. So creating the point, for example, don't see and confuse. Don't make more complicated. It's very, very easy. So when you cut a section like this, and you cut a section here, okay, and you are saying in this in the under view, okay, how will it looks like? Getting the point is very easy. Getting this point is very easy, and getting this point is very easy, and connecting a line, creating a line based on these 3 points. Again, it's a very easy. And from this point, creating a perpendicular line. Again, it's a very easy. Well, creating these arcs, if you know this line and if you know the perpendicular line, and creating a curve, these two curves are again a very easy. So the base point, you have to create the first this curve itself. From this curve, take the center point of it and you can create a line. From this line, again the midpoint of this or like end point of this, again you can create a perpendicular line. We are going to see that today. Okay, so what are the nodes that you have to play to start with the geometry points? Okay, let me go with something. Yes, these are the nodes we generally have. I mean these are from the default libraries, but when it comes to the external packages, we have a lot. Initially we'll go with the basic one because you need a practice and don't rely on like the additional nodes or additional packages. Okay, so the let's say the first one. Let's say the first one, point out by coordinates. Most of you know like what does this point out by coordinates do? What does it do? What it'll do?
Place a point.
Data point.
Exactly. It will place a point if you connect the x value and if you connect the y value. It will create a point. Okay. Let's say number. And one more thing. Stop using the numbers. Stop using the numbers because if you understand the logic, then it is very easy what is happening. But when it comes to the picture, you are practicing it. For practice, while you practice, always I do prefer like a slider. I always prefer a slider, number slider and integer slider. Number sliders can be like a decimal, can have the decimal values in it, but the integer slider can't store any decimal values in it. Okay, so I'll go with the number slider always. Now, so fine, and set the value. So it is saying it's a minimum value and it's saying it's a maximum value. No maximum value. No, I don't know. I don't know like what would be the maximum value. Let's say always 10,000 something. Okay, 10,000 and step of like 0.1, 0.2, 0.3. What does it mean by step? So like how we played with like 0 double dot, 10 double dot, 0.2. So it's a minimum value, it's a starting value. Here it is like a minimum value, and the maximum value it can reach up to 10, or here it can reach up to 10,000, and with a step off in the sense like 0.2. Let me set this to the automatic. Now I can see 3 point 386.1, 386.2, 386.3, like that. If I set this to the step to the 0.3, now I can see with a point 3, point 7, point like that. Okay, let's say 0 point. Let me show you 0.3, 0.6, 0.9. That's it. And it's a 1. The final one is on 1. Okay, so 0, 0, 0.3, 0.6, 0.9, 1. Okay, well, if I set to the 2, again I'll see that point 2 factors. Okay, so always prefer number slider, and after placing the number slider you have to set the values based on your requirement. Okay, and while you're playing with the geometry, playing with a like a huge number like a 10,000, 20,000, 30,000. Why? Because if your units are in then you have to use like a 1,000 points, 2,000 points, like that. Okay, always set your project units while you're playing with the geometry. Always set your project units to the meters. Must. The first thing that you have to set, it should be in a must, because like we can easily play with the smallest numbers like 2.1. It's a 2.1 meter. So 1.65 meter, 1.37 meter. It's very easy to pronounce. Don't say it's like 2,000, 3,000. No, don't use any multiply with 1,000 times. Okay, so the first point you have to remember that playing with a while playing with the geometry, it's a setting the values and use a slider. Set the units and using the slider and other stuff. Let's say I have a 10 meters line. I have a 10 meters line. uh, the line always starts with a zero, with a zero, and the other end we called as a one. Okay, well, with a step of like one, let it be. So I don't see any round figure, I don't see any like decimal values, I don't see any decimal values here. Okay, even it won't return even. So fine. So number slider, the x value is 2 now, where it has placed one new point, and you can see instantly when I select this, you can see that instantly the selection. When I select this node, okay, see there is a point and it has created one, like it's showing like x and y. I'm sorry, x and y, but there is no z here because we don't have a z. If I connect this to this, now I can see x, y, and z as well. Okay, well, no, I don't want to play with the numbers. I want to place myself. Can I control the point, the geometry? Yes. Press Control B. instantly. So it switches. The first one is project units. Set the project units. Okay, and set the project units. And the second one is you have to use a slider all the time. Okay, and third thing, isolation. I mean, switching the geometry. Control B is a shortcut. Switch to geometry view. Switch to geometry view, and control plus I. Very very important. Very very important when you're playing with the geometry, because control I isolates the geometry is a very star and forward slash. Okay, so isolate means, for example, if I press control I, what I'm playing with that exactly, I can see only that particular geometry. I can't see anything else. It would be there, but I can't see. Okay, so I'm playing with this and press control B. Now zoom in, and I can hold this. See, I can see the lines. I can see the green blue line, I can see the red line, and I can see the green line. So once the line is showing, like, you can start dragging up to that direction, and the number slider will be added automatically here, and that should be on the other side, and that the z axis would be on the some other height. And use the right mouse click, and you can see that, no, it has to be more. Okay, and this has to be exactly on this point. And if there are any like a decimal values, you don't need to worry about it, you can reset it here later. Okay, and in the y direction, rotate it. Mm, sometimes it gets stuck. Okay, and in the y direction, yeah, I'm perfect. Now let me cross check the values. So it is around like a 4 and 6.5 and 6.5. No, this is actually value 7. Set the round figures. So you can set it later. Okay, so if you have any confusion like where the point has to be placed, so use the geometry thing and set the point. And now when I click on the point, we have a geometry, but you can't see, all are like grayed out. Okay, if I press control I can see all the geometry back again. And this geometry, and you are going to play with some sort of a geometry, and there are a lot of reference points itself. There are a lot of reference lines, reference planes, reference coordinate systems. So all they're like for reference for you. So to place one line, you have to play with the entire 20 to 30 nodes likewise. Okay, well, let's see. Now this is my point, it's my another point. Okay, so this is like a, it doesn't have any z value, and it has a z value, that's it. Okay, well, what do you mean by point dot add? What do you mean by point dot add? No, I already have a point. I don't want to disturb this, and I want to create a one more point. Now the x, I mean like 7 and 4. Now I want to create like a two more points on the same vertical. Like x has to be remain same, and the z value has to be like a 4, 6, 8, 10, 12. I need some sort of a points. Then what do? I will be using this point dot add. I'll be using this point dot add. So control C, control V, point dot add. Okay. So these are query. I'll show you this later. So point dot add now. When I connect the point to this point, it holds 774. Okay, vector to add. What do you mean by vector? It means 4 is a direction. So x is a direction and y is a direction, z is a direction. So point denotes a location, in the sense the location have a 3 different vectors. The point, every point has a 3 different vectors mostly. I mean, if it is a 3D component, if it's a 3D element, every point it has a 3 different like directions: x direction, y direction, z direction. The same directions we generally call as a dimensions again. Three dimensions: x dimension, y dimension, and z dimension. Okay, so these dimensions, now we are going to play with the vectors. So if I want to change only the z direction, then what to do? The direction denotes, I mean, it has another name which called vector. I'll show you that what do you mean by vector. Okay, so for now I want to create a vector dot by coordinates. I want to change the coordinate system, so vector dot by coordinates. Now it is expecting a vector, so I connected the vector to it. This expected a point and I connected a point to it. Okay, well, is there any difference on it? No. 774 remains same. Okay, now if I change the x value here, it will reflect here. If I change the y value here, it reflect here. So if I change the z value here, it will reflect here. How? Addition, which is adding, because I'm saying this, I have a point and I want to change, I want to add a point to y. Let's say I don't use numbers here, I'll use a slider. Always, always till the end of the training, I'll be using the sliders only. Okay, so let's say, actually we have two different kind of an inputs, guys. One is like a constant in the sense, what is this? Constant in the sense, it has a I mean, if you decided there is a value that's a constant and there is no change in it, then it's called constant. And if it is a variable, it's varying, okay, then it's called flexible. For most of the geometry, when you're playing with any geometry, you have to understand there is a flexible inputs required. It's a constant input, and it's a flexible input. So play with the flexible inputs. You'll be using like slider. That's the best option. Okay. So number slider. When I connect the x to it, now see, the y remains same, the z remains same. Now I'm changing like one. It is adding one to it. We have a point dot subtract also. If you see this point dot subtract also. What does it do? Let me connect the same point to this, and let me connect the same vector to this. Now this is showing like a 6. It's creating a 6. It means one point has created on the, I mean, so let's see where is the actual point. So this is the point. Let me set 2 value here. Now you can see this is a point, original point, and this point which is not changing, that it remains same. It remains same. This is creating a new point. It's creating a new point, okay, with 8 direction. I mean, with the x value it's a 9, and with the x value it is a 5. So when I select this, the blue one highlights, this one other side, this one this side. No, let's say control I isolate the geometry, this side and the other side, and this is the main, this other side, and this is the other side. Okay, well, perfect, I'm done. So point dot add, point dot subtract. Okay, well, now let me change the y direction. It changed the direction. Why the direction? Because if you notice it, this is a red line. Press and hold that and change this. Now the y is in this direction. So that on the same direction itself, it changed. Now if I set to the x is this, the red line. Okay, so it keeps changing accordingly. If I set this to the z, so z means this, z. Okay, so that is on, the points were placed on this direction. Okay, perfect. Now so point dot add, point dot subtract. So this one, well, that's fine. Now what to do with this? I want to connect these 2 points to the lines later. We'll see this later. I'll show you this later. First, let me finish all the point nodes. Okay. So point dot vector dot by coordinates. Okay, fine. No, Rajesh, I don't want to play with the 1 point. I want to create like a 2 points on the top side and the 2 points on the bottom side, or else 5 points on the other side and 6 points on the other side. Now let's see this. we are called as, now we are going to call as a parameters. Parameter in the sense not like mark parameter string, I mean like a comments parameter. When it comes to the mathematical, parameter is something different. Clear? So mathematical is called like parameter in the sense it's like a value. It's like a value. Okay, the value in a different form. Now 0 double dot 0 double dot 10 double dot 2. Now I have a point. So these values are going to be added. Anyhow, 0 is not going to be added. So let's start with a 2 with a step of 2. Now this points are going to be added to the x value. Now see how many points were placed in one single click, because it's adding 7 plus 2 if it is a single one. I mean if it is a number. So number is a constant, flexible, and then one we called as a range. Remember this, ranges. So the always input when you're playing with anything, like the we have three kind of an inputs. One is a constant, and second one is a flexible, and third one is a range. Okay, so this is a range, and this is a flexible, and this is a constant. Okay, now range. So 7 plus 2, it is 9. And again 9 plus 2, I mean like 7 plus 4, 7 plus 6, 7 plus 8, in like 7 plus 8, 7 plus 10. So I got the different set of points, and these are the points. And why this? Again, because vector dot sub the same like subtract, so it is creating on the other hand, other side as well. So that is why this. No, vector to subtract, not the same vector. Okay, Control C, Control V, Control C, Control V, not the X. I want the Y, and when I connect this to this, now it created another set of lines now. So I have a this set of lines. Now I want to connect this. I want to connect this line with this line, with this line, with this line, with this line, this with this line. I mean the point. So this point with this point. I want to draw like this, and I want to connect all the lines. I'm sorry. I want to connect all the lines, all the points. I want to connect all the points together. Okay. So well, and I will convert that into the surface, and I'll place one chair here. I'll place one chair here, chair here, chair here, chair, and this is our theater screen. Let's consider these are theater screen. Whatever. Okay. So creating, like, understand, you have to understand the points. We're going to play with the points now. Okay, well, I'm done. So constant input, flexible input, and range input. Do you have any doubts in point dot add and point dot subtract? Do you have any doubts in point dot add and point dot subtract? No.
No.
Very good. So
No.
point as vector. So vector is a very very important concept. Even sometimes I do confuse a lot, like in which vector, with which vector like we are going to play with, because the coordinate systems keep changing from one point to the another point. The way you place it depends also. Okay, so it has to be in a unique, and it has to be like exactly, you have to maintain a proper structure from the beginning to the end. So you have to be very clear. Okay. Just give me a second. Hmm. Okay, well, so point as vector. What do you mean by point as vector? When you connect any point, it will consider as a vector. So we'll see this vector part later, not now. Okay, so what do you mean by point dot origin? What do you mean by point dot origin? So if you have any, it means it will return the origin point. It returns the origin point. In my case, this is going to be the origin point. If I want to start playing with something, this is the origin point. No, I don't want to play with this origin point. My origin point, my project origin point is something else. My origin point is something else. Then it returns the same thing. Don't worry, I'll explain you this point dot origin later. Okay, so point out by cylindrical coordinates. What do you mean by cylindrical coordinates again here? What do you mean by cylindrical coordinates? Anyone? What do you mean by cylindrical coordinates?
3D element coordinates.
3D element coordinates. 3D element coordinates means slow. Point out by cylindrical coordinates, and it is expecting, what is it is expecting? Coordinate system. What do you mean by CS? What do you mean by CS? What do you mean by CS? Whenever the cursor, coordinate system, it is expecting a coordinate system. It is expecting the coordinate system. Okay, and I want the coordinate system now. I want the coordinate system now. How can I get the coordinate system? We have a node called, understand, coordinate system, type coordinate system dot by, and now I'll see coordinate system dot origin. This is a query node. It's a query node. See, don't place any, if you're playing with any actions or any creation nodes, okay, just no problem. Okay, so geometry. Okay, this is a query. Okay, and these are like a zap icons. And this is like a plus icon. Plus icon in the sense creation node. So I want to create something. So don't get confused like why all this stuff. Just go with the like icons. Just try to understand by the icons. Now, where identity by coordinate by horizon. By horizon. So coordinate system by origin, and it needs x and y value. X and y value. Again, it needs an input. No, I don't want set any inputs. Let me set. Okay, I have one more. Oh, this is also expecting x, y, z value. If I connect the x, y, z, it will create the coordinate system. See, it has already created one. Let me delete. Let me delete. See, there is no coordinate system now. Press Ctrl Z. Now it has created one coordinate system. This created one coordinate system. Well, no. By horizon. By horizon. Oh, so I have an horizon point. When I connect this to this, it's created one coordinate system now. And this is a horizon point. Well, I don't want to play with this. No, if you know the values like x and y, you can create it. Or else, let me show you. Anyhow, I'll explain this later. Coordinate systems. Okay, like how to create a multiple coordinate systems at every floor, at every level. So at different positions. I'll show this later. For now, try to understand. I already have a horizon point. I connected the horizon point to this, and this coordinate system is I connected this to this, and now from this point, okay, these have already a default values. If you notice it, how can I say the default value is already assigned? Italic.
Italic.
Italic. Angle is an italic text. Elevation is an italic text. Radius is also an italic text. So there are already default values. Let me see what is the angle here. What is the angle here? Let's see. I don't know what should I connect here. I'll say I'll use a like constant input. It's like a 45. Or else I'll use slider. I'll use always like a flexible. So I'll use a slider. I'll use a number slider, and I'll set the maximum value 100. Leave that as it is. So fine. I will set like some sort of a 45. Step would be 1. So when I connect this to the angle, so when I change this, if you notice that, okay, so this angle, no, so angle always should be like a 360. When I'm playing with the angle, I can change this value to 360. So okay, that is rotating. It's like where it has started, 0 value, 0 and 360. Okay, perfect. Now what if I set like 720? What if I set like 720? Let me see. Oh, still it is having the second rotation. So it is having the second rotation. Okay. Well, okay, fine, whatever. Let's keep that as it is. Now I understand angle. So what is the elevation now? So elevation also, let's say it's an angle. angle. Okay, now I need a one more, and this is an elevation. Name everything, don't leave that as it is like a number slider. Okay, name it. Elevation, for your understanding only, elevation. And elevation, my building height is around like a uh, 10 meters. So maximum it would be like a no 4 8 12 16, maximum 16 meter, with the 16 meter. Okay, well, the elevation, that's fine. So elevation, now see, I can see a point here, and if I change this angle, if I change the angle, that is rotating, on the 10th 10 I mean with the height of a 10 meters, with the height of a 10 meters. If I set this, now if I rotating it, it is rotating at like a 2 meter, it is rotating at 4 meter. Clear? Now what about the radius? Okay, i'll copy paste and I'll set radius. So the radius is 4. When I connect this to this, oh, now I can see, if I rotate this, now it is using radius. Oh, if I set the radius set to 6 8, okay, perfect, 7. So when I change this, now that is how it is like rotating. So this is called flexible input. So these are flexible inputs. Okay, no, let me pull that here. Flexible inputs, disconnect. No, I want to play like a cylindrical coordinates. I want to play with some sort of ranges. Then we'll see. So I know angle. angle angle so angle starts with a 0 with the end of 360. No, I'll just go with a 90 degrees only for now, and with a step of every 15 degrees. With every 15 degrees angle, when I connect this, see, it has placed some points. Got it, guys? Got it? Guys, got it? Now, well, angle. So how many points are there? Total 7 points. So one, when I select this, 1, 2, 3, 4, 5, 6, 7. Okay, 7 points were placed. I'm so sorry. My throat was completely bad due to like journey. Okay, so angle. And what about the elevation? And there is no elevation. They lied on a they lied on the same plane itself, correct? On the same z direction. Well, when it comes to the elevation, my first point has to be at 0, and my second point, let me change the value, not 90, I'll set it to 180. I can see 180 now with a step of 15 degrees. Okay, perfect, man. Okay, well, if I say 270, okay, well, perfect. Okay, I'll just go with the 270 only. Well, elevation. What do you mean by elevation? Total, I have a 19 points. 19 points should be in a different elevations. So what is saying? My height is it should start with a 0. My building height is around let's say 8 meter. I already said something 8 meter with step of 19. So this is the reason why I took like essentials. You understand? You can easily understand the ranges now. Why I'm playing with this stuff. Am I right, guys? Are you clear? Okay.
Yes.
So that is why we took an essentials, and we are going to play with the lasings and everything. Like why we took an essentials, you will come to know in our future sessions, because the picture should be very clear when you're playing with any concept. Okay. Now this is called elevation. This is called elevation. Now when I connect this elevation to this elevation, total I have a 19 points. I have a 19 points. I have a 19 elements. I have a 19 angles. I have a 19 angles, and I want to place it exactly 19. So if I set 20, it gives a different result. I don't want to see that. I don't want to see that. That is the reason I have a 19 values and I got the 19. No, if I want to change it, if I want to make it fixed, let's say set elevation ELE. So let's set ELE elevation. Let's say ELV elevation. Now list dot count. List dot count. So I'll get this count here and I'll get the count here. So it gives the perfect count now. And you can see the same geometry. Even from the top view, it looks like the same 270 only. It gives you the 270 degrees. Perfect. But the elevation, this is how actually it looks like. Got it, guys? And what about the radius? What about the radius? Okay, the radius, it is like a, I mean, you can change the radius accordingly, or else you can play, I mean, the constant radius as well. The radius, it should be like, let's say, 10. When I connect this to this, 10 meters, no? Let me set only 2 meters. Let me set 4. Okay. So it's changing the shape of it. It's changing the shape of it. So now from the top view, that is, it looks like a circle. It looks like a circle, but that is not a circle. And this is how actually it looks like. So this is why, this is what I'm saying. Point out by cylindrical coordinates. Point by cylindrical coordinates. Okay. So it looks like a cylinder. It looks like a cylinder. Cylinder, to create a cylinder, it needs an angle, elevation, and the radius. Okay, perfect. Now how to connect all these points into the lines, we are going to see in a next thing. Okay. Well, so this is fine. And the by Cartesian coordinate system, what is this point out by Cartesian coordinate system? Let's keep that aside. Okay, so this is another one. For example, the default coordinate system is this, but I don't want this coordinate system. I want to create my own like a coordinate system, and from that coordinate system I want to place the points. I want to place the lines or curves or geometry from that coordinate system. Let me see. This is actually the default coordinate system is 0, 0, 0. No, I don't want that. Let's say point dot, I'll go with coordinate system by x, y, z value. So I'll set the default value. I'll go with a slider. I always go with a slider. I don't use numbers now. So let me set it 5. When I connect this to this, see, now 1 is here. And when I connect this, so that's somewhere. And okay, well, that is fine for me. Now, see, that is where if I start placing the points, x value, slider again. I'll use a slider again. So let's set 5. Now when I connect this to x value, from this point, it is placing the point after 5. So what is this? Yeah. See, when I keep changing here, it's closing. And when I set 0, so that would be here. So the x value something like 2, and y value again, it's like let's set 2, and the z value also, it's like set 2. Now if you know the coordinate point, I mean, for example, if you want to create any point, always it will the default, for example, point dot by coordinates, it is taking from here. If you use whatever, it'll start placing the point from here itself. No, man, I have my own coordinate system. Don't use this coordinate system, the default one. I'm going to assign a coordinate system, and from that I want to place the points. So x, y, z. Okay, now this is my actual point. Now this is called coordinate system. We have a lot in coordinate systems. We will see later. Okay, well, so that is called Cartesian coordinate. Cartesian means you have a specific value. If you don't use a Cartesian, if I remove the Cartesian, it's a point out by coordinates. Point out by coordinates in the sense, it will consider the default one. No, if you know the coordinate let's say, here's, I mean, just now I googled it for you to show. Where is that? Oh, hey, there's a picture I've seen now. Okay, anyhow, Cartesian coordinate system, whatever. Cartesian coordinate system, this is how actually it looks like. So there are, I told you there are 4 quadrants. Which is the best one to explain the coordinate quadrants? Anyhow, I'll explain this later, not now. Okay. So these are the quadrants, guys. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So from this point you need a like a 3x, 2y, and if there is an z, again 3 comma 2 comma 4 something. Okay, so that is how it would be. Well, so this is my point now, so hope you understand. And what else we have? Point out spherical coordinates, that is almost similar to the cylindrical coordinates. Play with this spherical coordinates, okay? Because it's a time-based process explaining the same. What do you mean by angle? It's a double. Elevation is a double, and radius is also double. So play with the like a phi. Again, it is an angle down from the z-axis in the degrees. So here it is an angle. This is also an angle. So theta, it is like the rotation around the sphere from the x-axis in degrees. So the same thing like an elevation, okay? And the radius, again, that is a radius. Play with this later. You play with this later, okay? I'm gonna share you this.
Yeah. Hi Rajesh, I have a doubt in this cylindrical coordinate
Mm,
node.
mm.
Yeah, when we are providing a angle value, then how it's selecting that it should rotate in XY plane? When you are providing a value to angle, then it is making rotate in XY plane.
So okay, well, in that case, you have to change the coordinate system again, where we have our another set of nodes. Like how, I mean, generally the default one is always an x. For most of the nodes, the default one, it is always an x. Okay, so if you want to change this, you will be using this and you will be creating these points, and you have to translate into x or y. We'll see the transformations. Who asked this?
Right, sir.
Sure. Okay. So we have a transformations concept again. So I'll explain you that. So I don't want to confuse you bringing all the things in one block itself. I'm going to use the same examples again and again and again in with a, I mean, in a different sessions. Okay. Clear? Clear?
Yeah,
I'll
okay.
explain you. I'll explain you. Don't worry. Clear. Now, so point by cylindrical coordinates, use the same one. And point dot prune duplicates. What do you mean by point dot prune duplicates? For example, point dot prune duplicates will be we will be using when like what do you say? What is a software? Scan to BIM. Scan to BIM. So in scan to BIM, we have a point. For example, I see I have, there are, I mean, it looks like this is a pipe actually, okay, or this is a duct, or this is a structural column. So next to this column, there are a lot of points close to it. There are a lot of points close to it, correct? There are a lot of points close to it. Lot of points close to it. To remove the points, so we have to set the tolerance. Don't consider the points with a set of some sort of a tolerance. Okay, for example, when I connect the points to it, 100 points, out of those 100 points, the third point and the seventh point and the 10th point, or like 15 points, are very close to the another point with a set of a tolerance. So when I hover the cursor on it, read the description. Prune points to exclude the duplicates within the tolerance of an included points. So it will ignore, I mean, if I set the tolerance value to the 10, I have a point. I have a point here. Let's say I have a point here, and I have a one more point, and I have a one more point, and I have one more point here. Now, this is going to be my point, and the tolerance, if I set this is 2, this is 2, and this is up to 4, and this is 5. Now I'll set the distance to 3. So the three radius, within the three radius, whatever the points it was there, it will be it will be removed. I can see the 4 point and I can see the 5 point as a list here. Prune duplicates. Okay, we are going to play with this prune duplicates later. I'll show you how to create some sort of a messy and how do you use it, the tolerance value. And point dot project projection also, it's a in future sessions, like we are going to play with the transformations and projections. We'll say later, we'll see this later. Okay, because I think we haven't covered that. We haven't there are some sort of a lines, there are some sort of a lines, and that lines has to be exactly like projected on a different surface, like on a different surface. So how do you exactly use it? We're going to see that later. Okay, it's called projections. Well, now these are the general nodes what we can play with the points. Okay, now how to play with the lines, how to play with the lines. Let me same as point dot final. Should I replace this? Is that in the set of point I used it? No. Okay. Well, let me replace it. Well, so done. The second one we are going to play with the lines. Second one we are going to play with the lines. We'll copy those and we'll use it here. Control N. Open this line. We have very few nodes here. Let me copy and point final. And I paste it here. I'm pasting. I'm just copied here. Okay. The first one, the most we know, the first one is this line dot by tangency later. Direction is also later. Okay. Okay. Perfect. So you know the points, you know the start point and you know the end point. If you want to connect the lines, if you want to connect the start points and end point lines, then you have to use this. You have to create a line. If you want to create a line with a start point and end point, so what are the start point and what are the end points? Now in my case, for example, point dot, I think we already used it before, used here. So this is a point and this is another point. Let me connect these two, point and this point. So I'll use this point and I'll use this point as an endpoint. Okay, for now. So what I do, I'll connect this point to this point, start point, and this is going to be my end point. Now I can see the line. Now I can see the line that is called line dot by start point end point. Okay, well, this is fine. But what about the second one? Line dot by start point, direction and length. Okay, no, actually the line point, okay, the first one, how can I mean without endpoint, if there is no endpoint, you have to return the length of it and the direction of it, the length of it and the direction of it. Here you cannot control the length of it, you cannot control the length created by itself when you connect the second point to it. But here you can you can control the length, you can control the length, you can change the direction. Even you can get the same direction here as well. Okay, you can get the same direction here as well. Now, but what about the length? Okay, well, let me see. Now I want to use the same start point, so I'll be using the start point here. I'll use the same start point. In the direction, And the direction. So what about the direction? How to get the direction? When I hover the cursor on it, oh, that is expecting the vector. That is expecting the vector. So what do I do? Vector dot by coordinates. Vector dot by coordinates. Vector dot by coordinates. I want to use the same endpoint here. I want to use the same endpoint. I want to use the same start point, but I don't want this much length. I don't want this much length. I want to get only some sort of a length. That's it. So what I do, I have a line. I have a line. So the line can returns a vector. A line can returns a vector. So how to do that? Vector dot by line. So vector dot by 2 points also. I can use like seeing start point and end point. Now it is returning the vector direction. So this direction I can connect this as a direction. See, if you notice it, it is giving you the same, it is passing in the same line itself. It's passing on the same line, the same vector direction. And now I can set the length. Length is like something around that is 10, no? It's 10.677 something. Let me set when I connect this length. See, when I expanding, let me set to 15, the maximum value, so that I can easily see the black color line which is expanding till some extent. Okay, I want up to here. That's it. No, I want to go beyond than this. Then that is how. So the line with the step of like using the vectors. This is using the points. No, I don't want to use the points. I want to play with the line. I already have a line, vector dot by line. Same thing. When I connect the line to this, it returns the same vector. It returns the same vector. Okay. That vector can be connected this to this, and still it returns the same output. Still it returns the same output. If I change it, that's it. If I change it, still it returns the same output. Okay. The vector. Okay, well, there are a lot you can play with. I mean, you have to understand this thing later. Okay, I'll explain you. Okay, well, the direction, and now the challenge is let me. I think we should have this somewhere playing with the lines. No, these are for lines. Okay. Uh, what are the notes we have? Line dot best fit through points. So this is not exactly the node what we are expecting to see. This won't return, but if they are running on the same vector, if they are on the same vector, then that would be the best option for this. Okay, you don't need to connect any points here. So list dot points. Let me stretch that here. Let me drag that here. Okay, so point dot. It is expecting the multiple points. So I'll be using list dot create. List dot create. When I connect this point and when I connect this point to this, now it has set of points. And when I connect this, best fit points. So now, we finish. Okay, so best fit points. Now still it returns the same line. If the point is somewhere else, if the point is somewhere else, like one point is here and the second point is here and the third point is somewhere else, then you can't expect the same. That returns a different result. If I want to play with the multiple points and the points have a different vectors, then it's a problem. Okay, how it will be played will be we'll see this later. Okay, so vector dot this one. Okay, and now line dot by tangency. Line dot by tangency. What is this line dot by tangency? What is the line dot by tangency? I think I have to explain something. The line dot direction. Mm, lined out by what, like, what would be the example? Ah, what would be the example? Let me show you. I think I have already explained you in the this picture. This picture. So one, I'm sorry, one, right, 1 to 2, and 2 to 3, and 3 to 4, and 4 to 5. So how can I set the angle here? I have a line, and with a 45 degrees angle, I want to create a one more line. How can I create that? How can I create that? Hmm? Let me go and see. How can I create this? Let me erase all the drawings. So using line dot, I need to know the vector directions as well. So what I do? So what I do? I already have a line. So where is the line? This is a line. So this is a line. So let me. This is the input actually you need, and vector by 2 points. Shall I remove this? Shall I remove this? Because this is going to be. This is for your reference. Okay. This is for your reference. Okay. So I already have a line. Now I want to start. I want to draw one line like using the start point. I mean the same point, the same origin point, the same origin point. I want to draw one line on the other direction. Then how to do that? Can anyone? Can anyone? I have a one more line. Let me check. You guys not responding. Point dot by. I'll use geometry dot rotate. That's the best example that I can explain you now. Geometry dot rotate. Now the geometry dot rotate expecting two. I mean there are two nodes actually. Geometry dot rotate. Geometry dot rotate. The first node it is expecting origin and axis and the degrees. I think which is more familiar to what I'm looking for. I have a line. So line is going to be my geometry. Okay, perfect. So I want to rotate this. I want to rotate this. What about the origin point? This is from which point I want to rotate this line. So this line has to be rotated like this in the this direction. So this is going to be the origin point. So where is this point? Start point. Where is this point? Let me erase all the drawings. Start point, right? So start point. So this is going to be the start point, and this is going to be the origin point. And what about the axis? So is it x-axis or y-axis or z-axis? When it comes to the picture, I'll be using vector dot type x-axis, vector dot x-axis, and instantly I'll convert this node to the code. I'll convert this node to the code. Okay, why? You will be knowing that later. Okay, so x-axis, y-axis. Now let me check. Is it going to be the y-axis or x-axis? Okay, x-axis. And what about the degrees? So degrees in the sense, I'll use a slider. I'll use a slider again. So this is slider. I'm sorry, degrees, and this is axis, not x-axis or y-axis, whatever it is. Okay, it's just an axis, and the degrees 360 degrees. No, 360 degrees. Well, with a step of 1, minimize this, and when I connect this to this, now when I keep changing the value, that is playing on the other direction. That's playing on the other direction, x-axis. Okay,
It should be y.
it should be y. Then instantly what I change, I'll change this y to the, I mean x to the y-axis. Why return something else? Why return something else? Is it? Is it the z-axis or what? Okay. Uh-huh. Okay, let me see now. I can see the z-axis. It's saying the degrees. And now when I set to the 0, it lays on a 0 again. It lays on a 0 again. So 0 is the actual state of it. And then if you want to change that value, so that is how it is rotating now. Okay, well, is it the same line or is it another line? It's another line. It's creating a duplicate. It's creating a duplicate, and this geometry is acting like a reference. It's acting like a reference. Now, I have two lines here, guys. This is a one line, and this is a second line. So this is the original line, and this is another line which is created another line. Now I want to know the angle between these two. I want to know the angle between these two. What is the angle? So what is the angle between these two? What is the degrees? What is the angle between these two? How do I get this? How do we get that? We have a node called what is a node actually? Vector dot angle. It's not angel, it's angle. That is expecting vector, other vector, rotation axis, not this one. Angle vector, two vectors. Okay, perfect. So these are two vectors. So using these two, I created one line. So I want to, it needs a vector. So I can get the vector by line here. Vector by line. So control C, control V. I'm sorry. Control C, control V. When I connect the line to this, it is giving me the vector. Okay, it's giving me the vector. For this line, it's giving me the vector. And for this line, I need a one more vector. Control C, control V. Okay. So when I connect this line to this, see, it is returning a line only. So this is giving me the another vector. Another vector. Now I just want to know what is the degrees. Vector and another vector. Now it is showing me like a 26 degrees angle. It's showing me the 26 degrees angle. So the angle between these two lines are 26. Okay, it's a 26. Okay, so it's a 26. Okay, perfect. So understand now. Okay, well, this is 26. Fine. Now vector dot x-axis. This is in a positive. This is just in a positive value. What if I want to know? I mean, if I want to play with the same angle but with a negative direction, with the negative degrees, then what to do? Create a one more. Create a one more like slide formula x. I mean like axis, negative axis. So minus 360 degrees. Axis minus 360. So I already have a degrees. So when I connect this to this,
Rajesh,
yeah,
what is meant by negative degrees? I didn't
negative.
understand.
This is almost same, but you will play in a different direction. I mean, for
Anti-clockwise.
exactly anti-clockwise. So you want to play with an anti-clockwise direction. So how do you play with it? What is the actual value? So if it is at 229, so it is which is equal to 331, which is equal to 331. For example, I have created this line when I using this degrees. So when I connect the 29, let's say 45. Let's say 45. Okay, let's say 45. Now this is a 45 and this is minus 315. Like when I connect this 45 to this, now it is placed exactly on this. Now I want to draw the same line with a negative value, with a negative degrees value. Then what is the value here? Minus 315, correct? If I set minus 315, and when I connect this to this, it returns the same line. Clear? So this is a positive value and this is a negative value. That's it, nothing else. To get the negative value instantly, so you have to use this tip. Clear?
Okay. Okay.
So
Yeah.
let me connect this to this. Okay, fine. Now I want to create a one more line, guys. I want to create one more line. So I already have a one more line. I already have one more line, and I want to create a one more line from the endpoint. How to do that?
Rajesh, I have a doubt.
Hmm.
Actually, you are giving a value as 40 something, right?
Hmm.
But we are getting that point value. Can we create it accurate? So
What is the point?
the
Oh,
angle
this
between the
one.
two lines. Yes.
41.564. No, I mean, the vectors have a different and don't use any these kind of values, because vectors keep changing from x, y, because it is reading x direction, y direction, and z directions as well. You understand? So,
Okay.
obviously, you will definitely get that kind of deserts. No, I want the get accurate one. You can use like a math dot round. You can use a math dot round values again, math dot number.
मतलब
So when I connect this to this, so it returns a 42. It returns a 42. So if you want to set the 42, you need, if you want to control this, I shown you last day. I just shown you just few minutes back.
లుంగి ప్యాంటు కూడా
Hey,
నాకు లుంగి
Bharat,
ఇవ్వు కొత్త.
Bharat, Bharat, you're on. Unmute, man. Okay, okay. So just now I explained some different example. Okay, well, I'll show you that later. Okay, you can control this. You can control this. I want exactly the 45 degrees. I want this with the actual vector direction and vector length and everything. You can control it. So we'll play with the rest of the vectors in a, maybe next to next session. Don't worry, I'll explain you that. Okay, but when you're
Okay.
playing with any model elements, this is common. This is common. Like you will definitely get this kind of a dist value. No, I want the actual 45 degrees only, the 45 degrees angle. Yeah, you can get it. You can get it. Okay, well,
Mm.
so this is the one, and I want to draw one more line. So where is a line? So this is the geometry. This is the geometry. From this, uh, if I want to start one line from here, what is the node? What is the node? I want to start. I want to draw one line from this point to the another direction. How? First, you have to understand what do you have with you right now. I have a start point and I have an end point. Correct? Correct? So if I
Yes.
want to get the end point, I want to start a line from the end point. So I have to extract the end point. Correct, guys? Simple logic. See, geometry is very easy if you keep playing with a if you keep playing. Otherwise, if you stop playing for like some time, getting that logic is very tough for you. Seriously, I'm telling you. Okay. So I need an endpoint. So can I get this endpoint from here? Yes, endpoint. So curve dot endpoint. Curve dot endpoint. So when I connect this to this, I got the endpoint. See, I got the point now. So from this point, I want to draw one line. I want to draw one line. Okay. So line dot, I'll use line dot. The direction to curve line is parallel. Line is vertical. Line dot by start point end point. Line dot by, I'll start typing by start point end point direction length. The same node what we use now. So from this point, it is going to be my point now, and in which direction I want, and what is the length. So slider. Let me set the 8.8. Okay, and the direction again it is expecting a vector. So you keep playing. These are like frequently used nodes when it comes to the geometry. Okay, so vector dot by coordinates. So when I connect the vector to this, what is it saying? Unable to create line because likely coincident because I haven't set any values here. Let me set slider. So instantly, what do you think when you don't read the error? Okay, maybe this is not the right node to place it. No, that's the right node. So when I change the direction of X and when I connect this to this, now I can see the line. Now I can see the line. Press Control I. I can see these lines. So now from this point, and this point, like whatever. So when I change this X to the Y, it reads in different direction. And when I change this to the Z, it changes into the different direction. Now this line and this line. Again, from this endpoint, I want to directly connect this to this point. How to do that? How to do that?
Mm,
Hmm? This is my
line by start
yes. Now line I have an endpoint, like
start
we have a
point and
start point and we have an endpoint. So curve dot endpoint. So curve dot endpoint. So when I connect this to this, okay. So I have an endpoint and what is this point here? So that's a base point, no? So line dot by start point and endpoint. And this is going to be my start point and endpoint is going to be this one, I think. Yep. So endpoint is going to be this. Now I'm perfect. So I'm done. Clear? So I'm done. Now I don't want to do like this. I want to play with, I want to connect like with a different lines, different set of lines. Then what do you do? Let me remove these two. Let me remove these two. And what do you do? I don't want this one now. So where is this line? You have to keep playing. You have to reorganize it. Okay, while explaining, it's very. I can't focusing on geometry dot rotate. Okay, this is a line, and this is another line. Okay, I have two lines now. So geometry dot rotate. I'll say first line. Don't change the name because you will get confused. Use Control W. First line. Okay, and Control C, Control V, and second line. Second line. This is very much important because you guys will definitely confuse when you're playing with us. So why did you create this? To get the vector. So Control G to get the angle between two lines. Okay, keep this aside. Keep this somewhere. Now this geometry, I want to split this geometry into the multiple points. Now we have seen like the points, how we can place the points. Now I have a line and I want to convert that line into the points. How to do that? Point at parameter. Point at parameter. So point at parameter. Okay. So when I connect the geometry to this and parameter. So parameter in the sense like it is going to be act like a 0 and the another end which is going to be act like a 1. Remember this. So place at 0 double dot 1. It's a constant. So when I connect this to this, it plays 2 points 1 and 2, 1 and 2, 1 and 2, 1 and 2. Just give me a second. Well, like this is a 0 and 1. Now I want 3 points 0 double dot 1 with a double dot 0.5. Oh, now I can see 3 points 0. This point is this, and midpoint is this, and this point is this. Now if I change this point to the 0.3, now 1 is, I mean 0, 1, 2, 3, and okay, there is another point. Okay, well, let me set this point to 0.2. Okay, I have an equal distributions like 0.2, 0.2, 0.2, 0.2, 0.2. Okay, well, I want to do the same thing. I want to do the same thing from the another line, valid. Okay, so this is the one. Control C, Control V, and this is another one. See, I have an lines. I mean, I have a points on this side and I have a points on this side. Okay, well, fine then. So we have a 0, 0, 0, 0, 0. Okay, hold on. Now, line dot start point, line dot end point. Now, this point are going to be my start point. And these points are going to be the end points. Huh. Now, see, I got a different kind of a shape. I got a different kind of a shape. But actually, no, my this point is going to be and connect this to this and this to this and this to this, but it was connected in a reverse direction. So what I do, I have to reverse one of the list, any of the list dot reverse, and I connect this to this. And when I connect this to this, now I see in a different direction. I can see the different, but still it is showing an error. Why? It means hover the cursor, read it. What is it saying exactly? Unable to create line points are likely coincident. It means they are overriding.
0, 0.
0, 0. Correct. So when I connect this to this, the fifth one it's returning because for this line, this is a point, and for this line, that's the same point. So you cannot create a line where they are exactly like a coincident. So that is the reason it's giving a error. Clear? Clear? Now when we have seen like how to create the points from the curves. No, you don't have any curves, but I want to create some sort of a points. How do you do that? Let me save this. Oh, this should be the line one. Okay, so file save as. Okay, I'll delete this later. Okay, so 1.2 line na 1.2 line 1.2, that's a line. Save it. Okay, perfect. Now, okay, well, let me show you something. I don't want to see all this geometry for now. Let me select all and right click and hide all geometry preview. I can't see any preview here. Now I want to place the point dot by coordinates. Point dot by coordinates. Now I place one point here. I placed one point here. Now, what do you mean by flexible and what do you mean by constant? Constant and flexible both are same. But when you're playing with the multiple points, you have to play with the ranges. So 0 double dot 10 double dot 2. So when I connect this to this, okay, so it has placed the points on the x direction. It has placed the points on the x direction. Okay, placed on the x direction. Okay, well, okay, fine. If I change this to the y, what will happen? Now, will the lacing works or not? Will the lacing works or not? If I change this auto to the short test, what will happen? It remains same. Change the lacing to the longest, remains same. Changing the lacing to the cross product remains same because it has only one constant in one input itself. One input, only one list, like one major list, and the rest of those are like small. 10, I mean, like 6, 1, 1. 6, 1, 1. No, nothing went wrong. It needs, I mean, if you want to play with the lacing, you must have two different set of lists. Okay, let me change this lacing to the auto. Now, when I connect this to the Y, what will happen? Let me Control C, Control V with a step of 3. With a step of 3. The step of 3. It's returning like 4 points. Now, when I connect this to this Y, oh, now I can see only 4 points. Why? Earlier I can see 6 points, but now I can see only 4 points. Why? Why, guys? Because of lacing. Shortest lacing. Because of the auto is acting like a shortest lacing. Now, if I change this lacing to the longest lacing, now the 4 points are on this side and the 2 points are. If I ignore this, so these 2 points are acting here, are going to act here somewhere, are going to act somewhere here. Let me set this to this. See, somewhere they're going to act somewhere here. Are you clear now? The same direction. They have a y direction, but the last point where there is a last point here. So the 9 is going to be like y for them and the x remains same. Okay, well, now if I change this lacing to the cross product, what will happen? Now see, it has created multiple points. It has created multiple points. I mean, each and every point which is going and create another, which is going and meet another set of a points. So now I have a total 6 into 4. Total I have a 24 points. I have total 24 points. I have total 24 points. So 0, 0. So this one, 0, 1 is this one. 0, 2 is the another one. 0, 4 is 0, 3 is another one. 1, 0. 1, 1. 1, 2. 1, 3. So that is how it is. That is how it is. Okay, well, fine. Now I want to convert these into the lines. I played with the lines and I placed the points. Now I want to convert this into the lines. How? Line dot by start point end point. So it is expecting a start point. I can't connect this. I can't connect this to this. Error. How should I connect? Guys, apply some common sense. I want to connect all these lines together. I want to connect all these lines together in other direction. So 0, okay, this and this and this. 0, 0, 0, 0, 0, 0, 0, 0. Okay, fine. How to connect the lines here? Is there any specific node that I can connect this? Then we played with a different set of node called line dot by best fit through points. Let me check whether will it work or not. It's working now because it is considering this point and this point, this are running on the same vector, and this is a list, and the first list create the first line, control I. So this set will create a first line. So the second set creates a second line, third set creates a third line, fourth set creates a fourth line, and fifth one and sixth one. That's it. But if I want this in this direction, I want to draw in this direction. How to do that? How to do that?
Is
Hey,
the transpose.
very good. Why you taking too much time to think? So transpose. So when I connect this point, okay, that's fine. Now these are going to act like, let me copy, Control C, Control V. So this is fine. And when I connect the list to the best fit points, now perfect. Perfect. Now I have a lines and I have a one more lines. So you have a lines and you have a lines. Now you want to get only wherever there is wherever the points are getting intersecting. Wherever the points are intersecting. No, I want to extend the lines. If I want to extend the lines, what to do? I want to extend these lines and I want to extend these lines. How to do? Curve dot extend. Curve dot extend. Curve dot extend. Okay, well, you have a lot of these are like coming under a different thing. Extend. There is a one more. There's a one more. There's a one more. There's a one more. There's a one more. Let me check. I want to extend this cows. Okay. Well, let me. Here is all the drawings. I have a cow. So they have extended and extended on other side. Okay, well, let me connect this, or else I can create a list dot create. I'll connect these two set of lines here. I'll create these two set of lines. Oh, okay, these are like creating another set of points now. No, I'll use list.join. You have to be very specific, like based on your requirement. So I don't want this has to be created like a another, I mean, multi-list. It should not be in L3. Okay, remove. I'll connect this and I'll connect this to this points. Now when I connect this to this, it extends on all the directions. Okay, well, now I want to see. I mean, I can increase the distance also. I can increase the distance also. Now, I want this wherever the extent points, wherever they are intersecting. I want to get those points. Now, what to do? Now, these 2 points I can use as like these lines I can use as a grids. These lines are extended as we can use those as a grids. We can use as a grids, and I want to place like this. I can convert this into the grids. Grid dot by curve. So grid dot by lines. So grid by lines. Now you have a curves again. So I want some sort of a distance. I'll use number. So while you're playing with the geometry, you have a lot of ideas to play with. Let's say 3 distance and the distance. Okay, perfect. Now these are the extended curves. So when I connect this again, list dot join, connect this and connect. I'm sorry, connect this to this, and I'll connect this to this. Now it was what's happening. Okay. So they are actually it is expecting lines, and we have a two line. We have a two line. If you connect any curve, those are expecting lines. Now I can see the grids on my face here. For now, try to understand. Okay. Well, I'm done. So they are like a grids. Now I want to get the grid intersection points. So how to get the intersection points? I have a two different set of curves. So curve dot intersection. We have a node called, I think, intersect all. When I connect all the curves together, it gives the intersection points. And these points, I want to place some sort of a columns. Based on this. And again, what I do, family instance dot by point, so I have a points with me, and I want to place the family types. Now uh, family types I can choose any like what are all this rectangular column, whatever it is, rectangular concrete column. When I connect this to this, they were placed. Let me go and check whether in which direction they are placed actually. So if I go and check in 3D, I can see, but I can see only four. Why? It's showing 96 here, but I can see only four. Why? Oh, they're playing on the same lines. I mean, they're total 24. But how to change it now? How to change that now? Whether the intersection points are the points correct? If the intersection points are right, then let me change this lacing to the cross product.
It says beam in the family type. Is it because of that?
I think this is not the right family, or else what we using it's something different. Why they placed total 24 columns were placed at the same time? Concrete rectangular column.
Rajesh, you have used the beam family instead of column,
Oh, is it?
I think.
Okay. This is a different one. I'm so sorry. Where is that column then? What is this connection column? It's a plate, huh? Where is
It is in a structural column.
what are all this? I'll go with this. Oh, this needs lines. This needs a lines. Let me check where are those. Okay, well, we'll do one thing. So where we have a points, where we have a points here, where we have a points, and I want to translate this. Let me show. Let me show you. I want the same points to be translated on the z direction. How to do that? How to do that? There is a node called translate. There is a node called translate. Geometry dot translate. Okay, so geometry dot translate. Geometry dot translate. So when I connect anything, let me see geometry dot translate. When I connect the geometry to this and the z translation, let me set 8 meters. Okay, when I connect this to this, I can see the points on the z direction with the 8-meter height. Now I want to convert this into the lines. How to convert this into the lines?
Start and
Line dot by start point and end point. Okay, well, connect these points to the start point and these points to the end point. Now I have a lines. I connect this into the lines. Okay, now if I want to create any structural column, okay, let's say column by curve, structure framing, column by curve. Now that is expecting a line, and when I connect this curves to this, and from level 1, so levels from level 1, connect this to this, and structural column type. So structural column types, structural column type. So when I connect this to this, done. I'm done with that. Let's go and check. I can see the structural columns. Clear? Clear? Is it clear? So that is how it would be
yes.
like using like a translations. So today we just played only with the points and we played with the lines. Okay. So in the next session, like we are going to play with like a curve, like NURBS curve, like and surfaces as well. Okay. Generally, there are few stuff to play with. A few stuff to play with. Like there are. Let me show you. You are going to play with, see the point. So the first thing is a point. So everything we should start with a point. And then how do you convert that point into the lines? How do you convert the point into the curve? I mean, the points into the curves and curves into the NURBS curve. NURBS curve, again, splitting that points into the lines. How do you do that? Okay, well, Now once you're done with the lines, then you will be playing with the planes and solids. What do you mean by planes and solids? If you see this picture, this is the geometry hierarchy type. The elements hierarchy type, it's completely different. Okay, this is a geometry data type hierarchy. Okay, so we have two things. One is a geometry type and second one is abstract type. So what do you mean by geometry type? XYZ, it's a point, it's a geometry. UV coordinate, again it's a geometry. Line is a geometry. Polygon is a geometry. Arc is a geometry. Circle is a geometry. Ellipse, nubs curve, polycurve. We are going to see this tomorrow. Okay, and you have the curve, you have the arc. How do I convert that arc into the surface? How do I convert the circle into the surface? How do I convert ellipse into the surface? How do I convert the nubs curve into the surface? How do you convert the polycurve into the surface? We'll see that later. Now you have a surfaces. And how do you convert this nub surface into the solid? Geometry. All these are like a geometry. But when it comes to the abstract type, they are not like a geometry. They are something different. They are playing with the orientations, vectors, directions. I mean, like a planes, coordinate systems. Okay, and vertices, and edges, faces. So all these are like a abstract types. Okay, for example, if you draw any, like if you, I mean, when you're playing with any geometry, you have a you have to see every point with a like a specific shapes, geometry shapes. So here this is a, what is a shape?
Where
Square. This one,
Rectangle.
this one,
Triangle.
this one is
semicircle,
semicircle. So again, where else we have? What about this?
ellipse,
Very good. This one, squares
Again
again.
square.
Rectangle.
Correct. So we are playing with a different kind of a you have to understand, okay, where, how can I achieve this? Some of the shapes will achieve by themselves and some of them, like, you have to create your own, create by your own. Okay, like how we are playing with a geometry, why you have to play with the geometry. So play with points and lines today. Okay, and if you have any doubts, please note down all the doubts and come on the next session. Okay, well, so we're going to play with, and where is an example that we are going to see this cows tomorrow, I mean later on. Abstract types, abstract type also, I'll explain you this later. That's it for today. Okay, so we completely played with the line and points, and of course we haven't played some sort of a stuff today. We are going to cover these topics in a later on sessions. Clear? In a future sessions. Clear, guys?
yeah, okay.
Clear?
Yes, yes.
Fine.
Yes.
Okay. So no more hurries. See, generally I'm going to share you all this. What is that? Where is that? I'm going to share you anyhow all the stuff like Kovi, Dynamo geometry, essential scripts. Okay, I'm going to share you all this. Okay, like how do you play with a polygon? Like what do you mean with topology, solids? And you mean I was set for more than uh, 2 hours, 2 to 3 hours to create entire all the scripts. Okay, like to separate whatever the, what are the other lines. Let's say line final. Okay, for example, if I want to play with the curves, we have a. Let me open it. What's wrong? See,
Rajesh, which day you will cover topic related to the adaptive point family in geometry section?
adaptive points. Even I can explain next session also. Okay, so adaptive points. How do you play? Because like you have to understand the paneling part. You have to understand the paneling part. Okay, these concepts, the basic concepts will be covered, and I am going to show you only few set of nodes. I'm today I explain you like a points and lines. So when it comes to the curve, I'll explain you few. And when it comes to the surface, I'm not here to explain each and every node how it works. You have to sit and do some sort of an R&D. You understand?
Yeah, but when it comes to the linear structures, adaptive points is a big concept for us, and I really request you to cover that point in detail.
Sure, sure,
I
sure.
mean, the topic in detail.
So,
Yeah.
to play with an adaptive components, you have to understand. Do you have any adaptive components that you already prepared?
Yes, I think in each of our projects we are using adaptive point families to create tunnels, bridges. So yeah, we have developed adaptive families.
If Can you share me those if possible, so that I can?
Maybe I can share samples which people might have created, but not the project family.
No problem. No problem. That's
As
fine.
the
Anything
project,
for my understanding. What
yeah,
kind of a families that you're using, so that I'll prepare a script before that, and I'll explain to you like how do you exactly use it. Clear?
sure.
Clear? Fine then. So, like all the inputs are expecting curve. See, these are like a curve nodes. These are all are like a curve nodes. If you connect any curve to this, if you connect any curve to this, oh, these many nodes, and we can't explain. We cannot cover all these topics. We cannot cover all these topics. So you have to sit and do some sort of R&D from your end, guys. Clear? Clear? Clear, everyone?
Yes.
Okay. Well, so
Yes.
we have a very less time actually to cover some sort of an essential points. Okay. Like for example, in a tunnel, you would like to draw some cable trays. So how do you convert that entire curve line into the points? So then points to the lines again, not to the curve, points to the line and that line because you can't draw a cable tray in this shape, correct? You can't
Mm.
draw any like conduits in this shape. So you have to split this point and you have to split this point, and this should be the straight line. And again one more point, and this should be the straight line. And one more point, it should be the straight line. And one more point, and it should be the straight line. Correct? So to understand all this stuff, how do you exactly use it? So we are going to see that in future sessions. Don't worry, I'll explain. Okay, clear, guys?
Yeah.
Clear?
Hi, Rajesh. I have one uh,
Yes,
suggestion. But we are not getting the Dynamo files that you are doing working on
I'll share it
in the
today. I'll
classroom.
share it today. I'll
Yeah,
share it all together today.
yeah,
Okay,
yeah.
fine.
Like previous sessions also, we are only getting
I'll share
YouTube
all together.
link.
I'll share
Yeah,
all together.
yeah.
Okay,
Thank you. Thank
fine.
you. Thank you. Bye.
Anything else?
And in last session, you was told you will share one book PDF, na?
Array, that is almost. I think I told that guy to publish it, post it. Let me check. Which login is this? Okay, my login only, personal login. Array, it's already uploaded. It's already uploaded. Cheat sheet. See, there is a PDF. Clear? Did you see this?
Okay.
Yeah.
It's already uploaded. Okay, Dynamo cheat sheet. Just go with that. Okay, it's already done.
Mm.
Fine then. So have a look into it because you will come to know a lot of questions when you're playing with that cheat sheet. Also, I haven't sit on it. I'll sit today or tomorrow. I have some like I have to code some project today. So we'll see. I'll set. Okay, clear, guys?
Okay.
Yep.
Okay.
See you.
Thank you, Rajesh. Thank you,
Thank you.
everyone.
Bye,
Bye.
Ganesh. Bye. See you. See you. Mhm. Just this.